So today we talk about machining drawing. During the webinars, I always try to make a machining drawing, but I never really show slowly what are the possibilities in the machining drawing. Hopefully this webinar will not be too boring. But I remember I spent so much time making machining drawings in the past without MDTools that I really enjoy when it's up to make a machining drawing with MDTools, because it helps you save a lot of time. So I will mix a bit between Solidworks and Inventor. There are some differences between the machining drawing. So the commands are the same, but the interaction is slightly different. So I will mix today between Solidworks and Inventor version. I started with a drawing. Let me take an A1. That's it. And so in both, let me also start a drawing in Inventor. Let me load also MDTools here. So basically, in both the environment, we have, let me just highlight, a set of commands. We always start from the first command on the left to create views, which normally you use it daily when you make a machining drawing. One difference between Solidworks and Inventor is that in Solidworks you have the options here, which basically allow you to configure all the single part of the software, while in Inventor you have each option controlled inside each command. So in SolidWorks, we can directly look at the configuration here doing the options, and we can control all the standard drawings. So an important parameter is the origin. So where we want to put the origin on a block. So when we go to the drawing view, we can define what is the drawing view, the primary drawing view in our block, which is now, for me, it's the front face. So let me open a block. So when we design, this will be my front face. So I expect to see this in front of in my drawing, and the same. I have the same drawing in Inventor, same model. So when we put the projections of the block in the drawing view, we can control what is the base view, so which is the view that is going in the center, and how we want to project our block. Basically, if the sixth view is at the right or down. There are some other options here. And these options are, if we want to display face name, what will be the height for the face name, if we want to have origins and axes. In general, there are footprints, if we want the envelope only or also the part names. Let me put envelope and PAN, part application name, and what will be the text height. If there are angle holes, we want to display an arrow showing the angle hole. If there are engraving text, the engraving text will be displayed in any case, even if they are cosmetic in the block. We want to mark export, and we may want to show internal details or undercuts and so on. Something that is very important, and the first time you run the command, it's important, because I remember once I made a mistake because I keep changing between first angle and third angle. Make sure that you select the correct projection type. The first time you do, then MDTools will remember, but make sure the first drawing you make with an MDTools, check which kind of projections you are selecting. Otherwise, you end up having problems with your manufacturing. Something that is very important is the face name. So you cannot control the face name in the machining drawing. You control the face name once in the part model. So if we go to the part model, So now let me show you. Let me try to put the views of my block. So now, when you do that with MDTools for Solidworks, MDTools for Solidworks will create all the 6 views with all the rules that you have selected. Which basically, I told MDTools to put to show the engraving, so there is a bounding box around the engravings. I told MDTools to put the face name with a 5mm text height, and this is the position. I also told MDTools not to put the origin, so no origins are available. Construction plugs are marked with a cross. And I didn't select the port application name. So in this case, as you see, I have only the envelope, but I could show the port application name. And this is showing A, B, P, and T ports for our. So the command can be run also from here. Although from the options, you define how each item is defined in our machining drawing. Something that is very important and has to do with the position of where the dimensions will start from is the origin. So you can control the origin for each face. Make sure that you select the origin first before putting the dimensions. Otherwise, then you need to rerun again the dimension. So basically, you can shift the origin, and automatically MDTools will project the origin for each face. If you want, you can define origin independently for each face. So basically, there you can shift the origin one by one for each face. Honestly, I always try to use the project. So I like, normally I use the top left corner, but you may need the bottom left or whatever according to your standards. In terms of dimensions, this dialog will allow you to define where you want to position the dimensions on each view. So as you see, we have a name for each view, front. And here, let's make a test. On the top face, I want the dimensions only on the top and right. So this will be the position for the dimension for the top face, just there. So let me apply and close. And let me start making the dimensions. So auto dimension, and I want to create the dimension. So in this case, MDTools will create the dimensions for us for all the views in the block. There is a difference in performance between MDTools in SolidWorks and Inventor for the machining drawing because there is a different interaction with the way the dimensions are created in the 2 different softwares. But basically, you don't need to do anything manually. Simply, MDTools will go through each views and make accordingly. Normally, so this is a new setup of SolidWorks I made a couple of days ago. So the first time I set it up, I don't like some settings. So let me show you the configuration that I normally have for the machining drawing. So now the dimensions is complete. And let me clean up my drawing. I don't like to see all the decimal places with 0. So those are controlled by SolidWorks options. So for the document properties on the dimensions, you can define on the ordinate dimension. Well, normally this is one setting which I don't like. I show you this. Normally I remove it. And then also for the linear, I don't want to display the. Okay, let me save it. So as you see, this is one setting that I normally switch off. I don't like to have the arrows in all the views because this is normally making a lot of confusion in the machining drawing. So this is something that I recommend you also to remove in both Inventor or Solidworks if you are using. So basically you go to the document properties, ordinate, and uncheck the display as chain dimensions. And then you click OK. So this will remove all the dimensions. I was mentioning something about the face name. So as you see now, there is a letter for a face name. Let me do the same in my MDTools for Inventor. So I show you where that setting is applied. So I open the same block. So this block is exactly the same. Simply one is in Inventor and one is made in SolidWorks. So to control the face name, you must run once the machine ID command. So machine ID command is controlling the style of machine IDs that you apply to your drawing. So in this case, in Inventor, I'm using this style. That means I have a number for a face and a number for the machine ID. And as you can see here, change face name 1, 2, 3, 4, 5, 6. So basically, MDTools is applying a name to each face in our block. So now, since in Inventor, in my case, I'm using the numbers, I expect that the machine drawing, so I can click OK. I'll show you what the machine ID is in the drawing. So now I expect that if I go to my drawing and create the views of my block, of the same block, I expect now to see the numbers for the origins. And as you see here, this is the number for the origin. So you can control number or letter for the face just by using the machine ID command. So at the same time, if I go back to my block webinar in SolidWorks and run the machine ID command, and now switch to a different machining style with grouping identical cavities, now I can make the drawing. And now I expect the views to be to have the same numbers. And now, as you can see, I have the numbers. So the top face is down, and I see number 1, 4, 2, 4, and so on, like in the other settings. And now I can see that A, B, and T are displayed because I selected that port application name is visible for my drawing. In terms of dimensions, we have the possibility to control which items we want to dimension. That's a new feature we started having two versions ago. So in the configuration for the drawing option, we can decide if we want to put the dimension just on particular entities, like I may want the dimension only on the cartridge valves. Not sure if that is making any sense for your application, but in this case, when I make the dimension, MDTools will put the dimensions only on the cartridge valves. So you know that in MDTools we have this concept of cavity type. So we have cartridge, bolt holes, ports, construction ports. So we are also able to extract detailed information from that. And now, as you see, I have only the dimensions for my cartridge valves and not for the rest. We can see an arrow for the inclination of the drills. And sometimes it makes sense to make cross sections to highlight that an inclined drill has a particular position. There is another possibility here. So basically, if you have seen other webinars, I most likely prefer to use the machining callout. There is an option for the machining callout that you can just use the machining callout for angle holes. This is something interesting because in this case, MDTools will put the machining callouts only on angle holes. So in case of angle holes, in this case, MDTools, you are giving some importance to the manufacturer, although you like maybe the drill chart, but in this case, we can highlight that there are some inclined drills in the drawing, just using the machining callouts only for the inclined drills. This block has an example of a simple inclination and compound angle. So as you see, this is a compound angle. So in this case, MDTools is listing beta and alpha. So beta is the inclination with respect to the face, and alpha is the rotation of the drill. So basically alpha 115 means that alpha is going on the, so let me just sketch an X and Y. So in this phase, this is the X axis and this is the Y axis. So 115 means that the direction is starting 0 from here and is going counterclockwise by 115 degrees, and exactly this is the direction that I find in the block. While beta is the inclination, so if that is the face, beta is this angle here, beta. So this is the drill that is going inside the face by beta. So it's the angle between the 90 degrees and the real angle that you are hitting the face. Let me try to configure now the machining chart. So if you remember, I run a command called machining ID. So which means basically that in my block, each item in the block, if I click edit, each item in the block has the component ID, which is the one that I specified when I made the drawing the first time, but I have also a machining ID. So you remember that I run machining ID, I selected a different machining ID sequence. So now the machining ID is 103. And if there are identical cavities in the block, like in this case, there are two identical geometries in my block. This one is 104A, and this one is 104B. In case of drill chart, I like to use the machining IDs instead of component IDs. This is not mandatory, but this is my preferred way because to me it makes more sense for the manufacturing. So let's try to build a machining chart format for today's webinar. So let me build a new machining chart, and my machining chart is called webinar. And I click new, and in my machining chart I want the name, which will be my machining ID, operation diameter depth. I want also the remarks. I want alpha and beta, and I may want the meet list. So basically the meet list is the list of intersections between different cavities in the block. So we can have several ways of a meet list. And let me configure one, and later I show you a different meet list. So if we go to the cavity naming and meet list, now we need to specify that our number scheme is number and alphabet, option 3, because we selected that one in the machining ID in MDTools. And let's say that we keep the first option. The third option is more complicated because in this case, MDTools will list start diameter, end diameter, start depth, end depth for all the intersections in the block. So these third options will end up creating a much larger, more complete drill chart with all the intersections details. If you don't use a CAM software, this drill chart will make sense because it will give you all the different depth where a drill is touching another drill. But I normally like just the standard meet list options, which is very helpful in finding out intersection and verify the block is correct. Under miscellaneous, you can define text height, shell margins, nothing major. We can define the precision. Maybe for the diameter, 1 decimal place is enough. For the depth, 1 decimal place is enough. For the position, 2 decimal place is better. And we can say no row separator. This is specific only to SolidWorks. This option is not available in Inventor. You can also customize the decimal separator if you like comma or period, as you prefer. If you don't like the name of the header, you can change it. I also want to add another item called quantity. Let me put it here. And we can sort differently. So let's say that remarks is up, operation, diameter, depth, are beta, quantity, and mate list. So now I have made my new drill chart list, and I can apply my settings. Now I want to use it. So I can select my webinar drill chart, and I want to insert in the drawing, starting from bottom left up to top left up to bottom right. Now MDTools is placing my drill chart in the drawing. Let's look at the drill chart. So, okay, that's that header. We will change it. So that should have been mate list. I'll check later in the settings. So as you see, we have the name, we have the remarks, operation, diameter, depth, alpha, beta, and quantity. So the fact that MDTools is able to create quantity, to specify quantities in the drawing, is because we specified a machining instruction in the block. So the machining ID, we said group identical cavities. So that is applying a letter grouping identical cavities in the block. And then in the configuration for the drill chart, also, we set up that our webinar drill chart is using the quantity. That's something odd. In the miscellaneous, we have the quantity, and we defined that the option 3, number and alphabet. If we select a different option numbering scheme, that will not have any, it will not group any item, because we must specify here how the numbering scheme are grouped together. Let me quickly go through the machining callout settings. Let's go back to the options. For the machining callout settings, you can specify for each rows, row 0, row 1, row 2, row 3, and these rows do match the machining sequence for the MDTools library. So if you remember, each cavity has 0, 1, 2, 3, 4, 5, and 6. All those are the rows. The columns are remarks, depth, diameter, and operation. So you can control how in each row you want to sort operation, remarks, diameter, and depth. So for instance, you can put remarks before operation, and so on. This will end up arranging the machining callout as you want in the drawing. In addition, you can put prefix and suffix for each operation, diameter, depth, and remarks in the drawing. So I see some questions. So let me answer to those questions. So if you make a change in the model, then MDTools will update the drawing. So let us make a small change in the drawing. So let's say that we just move a cavity by 1 millimeter to the left, and we go back to the drawing. And now MDTools will warn us there are some change. So it's now going to update the drawing. And now the drawing has been updated, and we will see the change. In this case, it was a dimension, a position of that cavity. Another question is, can we make a cross section? So yes, we can make a cross sections of an angle hole. This is using standard Inventor or Solidworks command. So we can go to the drawing view, make a section view, and you can define which kind of cross sections you want. And I did something wrong. Let me do it again. Well, let me make on this drill. Okay. And this is the cross sections where you have the detailed information, and then you can add annotation or whatever you need. So you can add the center lines and put dimensions. So in this case, MDTools is not making the cross sections for you. You will need to make the cross sections, and then you can put dimensions that you need. So we can put a smart dimension, and that's inclination, and so on. So you can put all the cross sections that you need with standard MDTools command. There is another questions about the settings. So if it is possible to share settings across users. So yes, all the settings and all MDTools settings can be shared across users. So basically in the setup, we have a program. Let me go to Vest. There is a program called Import and Export Settings, which is installed in both Inventor or Solidworks version. So now this is the 975 import and export setting tool. So this allows you to export your drawing settings, and not only for the machining drawing, but also for the part model, and also import on another machine. You must run this with Solidworks closed or Inventor closed. Additional information that you can add are the component ID, which you may want to add as maybe cavity footprint name. So basically in each, let me delete the cross sections. In each view, you can display the cavity name that is used for each entities, and then you can move where you want in the drawing. So this can help with understanding what type of cavity it is. I also forgot in my drawing to display the machining ID. Let's put it small, machining ID. So this is the number that matches a line in the drill chart. So that this is important, very important, because otherwise it is not possible to relate a geometry with the corresponding machining information in the block. We can also extract an engraved text chart, which is basically just a list of all the engravings that we have in the block, divided by face, what is the text height, and all the location. And also something that is interesting is a list of cavities in the block. So the list of cavities is basically can be very useful to prepare tools. So it's like a bill of material for the block. It is listing all the different entities that we have in the block. So this block has some winner cavities, so there are some cartridge valve. If you don't need all these columns, all this is customizable under options and in the cavity list, and you can switch off maybe the serial number or the feature type if you don't need. You can also define which entities you want in the list of cavities. So for instance, you could use the list of cavities just for the O-ring grooves. So you can uncheck everything, or maybe just for the construction port. So in this case, if I make the cavity list only for the construction ports, I have only a list of all the plugs that are needed in my block. So that is flexible because you can extract those kind of information directly in the machining drawing. Last information is the component and port list, which is basically the list of the items that you have in the block with the corresponding machining ID, footprint name, and where they are located in which phase. This is normally important if you need to relate with the corresponding diagram, hydraulic diagram. So in this case, this list is relating the item ID that was in the block coming from the diagram with the corresponding machining ID, what is the cavity name, and where this cavity is located, in which phase in the block it is located.